Worksheet 11. We're going to start with numbers 1 and 2. 1 and 2, we got to use our good old friend, PEMDAS, right? Please excuse my something, I forget. Dear Aunt Sally, yeah, some people have different ways to remember it, but PEMDAS is what we're going to use. What does the P stand for in PEMDAS? Parentheses. So we're going to solve what's inside the parentheses first, okay? What is 6 minus 3? 3. What is 4 plus 2? 6. Okay, we bring down the exponents. We bring down the plus sign. Now this is a mistake that I saw some people making yesterday, not necessarily in this class, but in another class. Okay, you got to this step, which is great. And then I saw people say, oh, that equals 9 to the 4th. Do you see how I got 9 to the 4th there? 6 plus 3 and 2 plus 2. But we can't just add the bases together like that. That's never been something we've learned. It's just one of those common mistakes that your brain might tell you to do. Do not do it. What is the next step in PEMDAS? E. Exponent, right? So let's solve these exponents. 3 squared is 3 times 3, which is 9. And 6 squared is 6 times 6, which is 36. Bring that plus sign down. Is there any M or D to do? Multiplication or division? No. Is there any A addition we can do? Yes, there is. 9 plus 36 gives us 45. And that's our answer for number 1. It's 45. All right? Follow the order. Parentheses, exponents. Multiply, divide, add, subtract. Okay? Same thing over here in number 2. First, we're going to solve the parentheses. 10 minus 8 gives us 2. Negative 4 plus 5. What does that give us? 1. Good. Oops, my voice cracked. We're going to bring our exponents down. 2 to the 3rd, that's 2 times 2 times 2, which is what? 8. And 1 squared is 1 times 1, which is 1. Add across. 8 plus 1 gives us 9. Like I said, if those were 2 questions you circled up and didn't know how to start, definitely make sure you have this written down. Thank you. Ooh, it's your ID cards.
What?
They reprinted everyone's ID cards for some reason. I'm not sure, but no, we're doing something. Okay. There's 1 and 2. PEMDAS. Nice and simple. Following that order every time. Questions I could answer about that? All right. Let's do some more PEMDAS in 3 and 4. A little bit different, but same order we're going to follow. We solve inside the parentheses first. What is 3 times 4? 12. And what is 12 squared? Is that 24? No, it is 144. Remember, it's not 12 times 2. It's 12 times itself 2 times. 12 times 12, 144. Here's another common mistake that I saw. People doing 3 squared plus 4 squared. Anyone know what property this is here? Distributive, right? We are not doing that here either. Okay, we would not get the answer we're looking for. The P comes first for a reason. Solve inside the parentheses, then solve the exponent. So there's a reason why we have PEMDAS, because that's the order it needs to go. So what's going to be the first step in number 4? Who can help me out with that? Devin, what's my first step in number 4? Multiply inside the parentheses. 5 times 2, what would that give us, Devin? 10. Now we have 10 to the power of 3, which is 10 times 10 times 10. And that equals 1,000. That's right. 10 times 10 is 100. And 100 times 10 is 1,000. All right? Questions I can answer up to this point. Quick show of thumbs. How do those first 4 numbers feel for you? Got thumbs up in the back. Thumbs up in the middle here. People sleeping in the front. Nope. Thumbs up in the front. Okay, good. Let's bring it on down to 5 and 6. Let me check, make sure what time we're at here. 926. Oh, we got time. So, number 5, what is this rule called here that we're going to use? I heard it up in the front. This is the product rule. Product rule. So remember in the product rule, we have like bases. What's my base here in number 5? X is my base. So if we're multiplying these like bases, what do we do with the exponents? Add them together. X to the power of 2 plus 8 plus what? 1. Good. Don't forget about that invisible 1. If these little notes that I'm adding in will help you on the test, please copy them down the same way. 2 plus 8 plus 1 gives us a new exponent of what?
X to the power of 11.
There we go. X to the power of 11 for our product rule.
We have to show it.
Yes, you do have to show this work here on the test. You must show all of your work on the test. It's not multiple choice. It is on paper. So if you just have an answer, unfortunately, I'm going to have to assume that you just looked at your neighbor's paper unless I see this work. Because this work shows me, oh, you know that when we multiply like bases, we add the exponents. If you just have this, yes, I know you can add 2 plus 8 plus 1 in your head. I assume at this point in your life, you know how to do that. I need to see this. And this, but mostly this. Yeah.
Is it okay I just put a plus sign like in between 2 and 8?
That's fine too. Yeah.
Okay, for number 3,
So, good. For number 3, you don't have to show me this. And even like the PEMDAS problems, I'm not as strict in terms of what I need to see because it's Math 7 review. At least put 12 squared equals 144 or 10 to the third equals 1,000. You don't have to break it all down like this, though. Good question. Osase? It's a good question. Let me see. 17. But a few of them are two-part questions, so 17, 18, 19, 20. Technically 20. It'll be fine. This was what, 24? Yeah. So, like numbers 1 and 2, right? They're the same idea, but you're only going to have one of those types of questions on the test. I just wanted 2 for additional practice. You know what I mean? All right. Good. Questions on 5? Looking good?
Yes.
Okay. You don't have to write what rule you used. Just show me that you know to add the exponents. Speaking of adding exponents, what rule are we going to use for number 6? Product rule. Same exact rule. What's different about number 6, though? Beautiful. Thank you, sir. We have 2 different variables. So this is where, if you remember, we would use our highlighters, which you don't have. That's okay. Where we'd take, okay, there's my y and my y. There's my z and my z. I can only combine y's with my y's and z's with my z's. So if we rearrange this, we have y to the 6th times y squared. That's kind of one of our problems. Good morning, Ashley. And we have z to the 3rd times z to the power of 1. That's right, another invisible 1. Thank you. Thank you very much. We're just going over number 11 right now, okay? Invisible 1. So we add these together. Y to the 6 plus 2 times z to the 3 plus 1. What's my new exponent for y? 8. And my new exponent for z is 4. Boom. There's my answer there. Double check your work. Make sure you don't just have something like y to the 12th or z to the 12th. If you have that, you combine all of them. You can only combine like bases. That's these 2 different colors here. All right? Yes?
I have a multiplication sign between y to the 8 and between 2.
So like this?
Yeah.
Same exact thing. Totally fine. You don't need it, but if it's there, it's fine. Good point. Good question. All right? So same idea as number 5, a little bit different because we got 2 different variables that we have to account for. We can't just combine them all together. We got to separate them. All right? Good. Okay, there's 5 and 6. Let's drop down to 7 and 8. What's my rule here in number 7 going to be? Oh, do you need this one? I got you. Here you go. And this we're recording, so you can go back tonight and get those first couple ones, all right? Number 7, what's this rule again? What is it? Still the product rule, exactly. We are still multiplying. Right? We are multiplying like bases. What's my base? 7 is my base. So we're going to do what with our exponents? Subtract. Add. Product rule, we add the exponents together. What does negative 20 plus 35 equal to? Positive 15. That's right. Should you take the time on the test tomorrow to multiply out 7 15 times? Should you go 7 times 7 times 7 times and figure out what that's equal to? No. Exactly, Brooklyn. Leave it just like this. Now, if we get something like 12 squared, do not leave it like that. It'll even say on the test, simplify completely. And what completely means is this right here. I want a whole number, not an exponent. Completely. Yeah, if it's something crazy like this, don't even bother. Even though you guys will have calculators, I don't want to see, 320 million, 7, blah, blah, blah. I don't want to see all that. 7 to the 15th is good. That's what we're looking for, okay? Number 8. Still the product rule, but technically this is 2.1e, the power of a product rule. And the difference between the product rule and the power of a product rule is these little numbers here. 3 and 6. What do we call 3 and 6? Coefficients. Thank you, Ida. Coefficients. Can you even see that? You can see it enough. Doesn't help. Coefficients, right? So those numbers in front, 3 and 6, we're going to have to do what with them? Do we want to add them? We're going to multiply them, exactly. 3 times 6 times a to the 5th times a to the 7th. All we did was take each of these 4 terms and rearrange them so that they're with their like terms. What is 3 times 6 going to give us? 18, thank you. And what do we do with these powers of A? That's right. They're the same base, A and A. We're multiplying, which is the product rule. So we add them together. 5 plus 7 gives us what? 12. That's right. 18A to the 12th. Ross? You don't have to do this step here. You can do this. I do want to see, just like before, I need to see that you're adding the exponents, but you can multiply 3 times 6 in your head if you're comfortable doing that. Yeah.
And is it alright if I do 3 times 6a minus?
Yes, yeah. You can combine, like this part here can go in place of here, and then you just do them both at the same time. Yes. I only broke it down step by step because we're going over it together. But yes, whatever you can do to make your life a little easier while still showing that you know what you're doing, you'll be okay. Essentially, I just don't want to see a straight up answer. Like, I know you can multiply those in your head. I know you can add 5 plus 7. I need to see at least one step of that process to prove that you know how you're doing that. Okay? I know it may seem like that's a lot or that I'm doing too much, but it's all for a reason. Trust me. It's for your benefit. All right, questions on 7 and 8. Not too bad? Hopefully? Good. Now let's switch it up. That's a whole lot of product rule. Let's do a little bit of our good friend, the quotient rule. Exactly. It starts with a Q. Quotient rule. As soon as we look at number 9, how do we know we need to use the quotient rule? It's over something. It's a fraction. Exactly. Thank you. I heard a couple people say it. It's a fraction. What's my base in this problem? B is my base, so we keep the base the same. And what do we do with these exponents downward? Subtract. 24 minus 12 gives us what? 12. 24 minus 12 is 12. Now let's think about this for a second. When you see 24 over 12, ignore the b's for a second. 24 over 12, what does your brain tell you that's equal to? 12, maybe, good. But if it was just 24 over 12 as a fraction, what's that equal to? 2, right? 24 divided by 12 would be 2. So this question is trying to trick you into dividing the exponents. Do you see what I'm saying? You have to remember that we are subtracting downward. When we're dividing the bases, we subtract the exponents. There's not a single rule we learned where you divide the exponents. Okay? Not a single rule we learned where you divide the exponents. Subtract them downward. All right? Now, number 10, we have 2 rules to use. Yeah, Ross. B to the 12th? Yeah, if you wrote b to the 12th over 1, that's fine too. Same thing. You don't need that over 1, but it's not technically like wrong. Mathematically, these are the same thing, so I'm not tripping over that. Number 10, we got 2 steps to do here, 2 different rules, all right? Let's clean up our denominator. What rule can we use in our denominator when we see that little multiplication dot? Product rule, good. We'll get to that one, Francisco, don't worry. But first, we got to clean up the bottom with our product rule. X to the 8th remains on top. And on the bottom, we're going to do what with our exponents again? Add them together. 4 plus negative 2. Right? But what happens when we see a plus next to a minus? It makes one big minus. That's right. Adding a negative number is the same as subtracting a number. 4 minus 2 gives us 2. Now we've got x to the 8 over x to the 2. Now what rule can we use? Quotient rule, exactly. Just like we saw in number 9, it's a fraction. My like base is x. So we subtract those exponents downward. 8 minus 2 gives us 6. Beautiful. X to the power of 6. X to the power of 6. Don't try and do too much all at once. And I know when you see something like this, your brain might tell you, oh, I got to break this up, expand it all out. The reason why we don't want to do this here is this negative exponent. Expanding out a negative exponent is a little more complicated than we need to worry about right now. Do the product rule first, then the quotient rule downward. Okay? Let's do that same thing again in number 11. Product rule at the top this time instead of the bottom. E to the 5 plus negative 3. Oh my god, my voice, dude. I think I'm getting sick. 5 plus negative 3 is equal to what? 2. Right? It's just 5 minus 3 over e to the 7th. Now there's 2 different ways we can go about doing this. It all depends on what you're more comfortable with. We have positive exponents, so one way we can do it is by expanding it out. E times e on the top. How many e's do I have on the bottom? 7. 3, 4, 5, 6, 7. How many pairs of e's can I now cancel out? 2 pairs of e's. One right there. One right there. Boom, boom. Everyone with me so far? How many e's do I have left on the bottom? E to the 5th on the bottom. But what's left on the top if everything cancels out? 1. We can't drop that 1. We have to leave it as 1. That's the first way you could do this. The second way you could do this is by using the quotient rule. We subtract downward e to the 2 minus 7. What is 2 minus 7? 5? Negative 5. Now we can't just leave it like this. What do we have to do when we see a negative exponent? Turn it into a fraction over 1. Once we have a fraction, we flip it around. 1 over e to the negative 5. And now that we've flipped it, we make that exponent positive. Same exact answer either way. It all depends on what you are more comfortable doing on your own. If you like expanding it out and canceling, which is what I prefer doing, absolutely do it that way. If you have a good grasp of negative exponents, which based on our quiz and our booklet, that's probably the most difficult concept for us to wrap our brains around, maybe the second option is not for you. But some of you've got this process down. You see a negative exponent, put it over 1, flip it around, make it positive. Either way, you get the same answer. Sound good? Okay. We got to get going because we got the whole backside too. Number 12. Looks similar, but is very different, right? What's the main difference here in number 12? What stands out? There's a different variable, that h, exactly. So let's expand this one out. How many g's do I have on the top? 3 of them. G times G times G. How many g's do I have on the bottom? 5. 1, 2, 3, 4, 5. And how many h's? 1. There's our invisible 1 again. Now we look for pairs to cancel. How many pairs of g's can we cancel out? 3 of them. 1, 2, 3 g's. All right. Now on the bottom, we have how many g's? 2. We'll make that g squared, g to the power of 2. How many h's do we have? 1. Couldn't do anything with that h, so it stays. And what's my numerator going to be? 1. Exactly. We can't just drop the numerator. Okay, if you put your answer as g squared h, that is wrong. 1 over g squared h is what we're looking for there. Yes?
So we put g to the power of 2h on the test. Would we get credit in the room?
I would probably just take 1 point off. So each question on the test is either worth like 2 or 3 points. So if you get at least to g squared h, you'll just get like half credit for that problem. Now if you get something like h to the 3rd, g to the 5th, I don't know how you would even get that, and then of course you wouldn't get any credit because it shows that you don't really know what you're doing there with that one, okay? All right, let us get to the back here. We got 20 minutes. That took 23 minutes. We can do it. It was 12 and 12. Uh-oh. All right, that's okay, because number 13, what's the answer to number 13? 1. Anything to the power of 0 is equal to 1, right? Okay. Right? Anything to the power of 0 is equal to 1 every single time. Number 14, what do we do with this negative exponent? We just talked about it. Turn it into a fraction over 1. Flip it around. 1 over 4 to the negative 3. Make it positive. 1 over 4 to the 3rd. And what is 4 to the 3rd? 64. The fraction is positive. Our exponent turned positive. That's the biggest thing to remember. 1 over 64. That's our answer there. Ida, what's up? This is another one of those that will say simplify completely. If you leave it as 1 over 4 to the third, I'll just knock a point off. We got to solve it out all the way. You're not going to get something like 1 over 7 to the 20th power. It will be doable. Okay? In fact, it'll even be a base of 2, which is even easier. So whenever you see completely, that should raise a red flag in your brain that I have to simplify it all the way. All right? Sound good? Number 14?
Yeah.
Okay. 15. What's the rule that we're going to use here called? Power rule. Again, we're raising a power to a power. Some of you might not even need to use the power rule, right? But if we did, we would multiply these two. Y to the 4 times 0 is y to the 0th, which is equal to 1. There we go. Now you could have just said, oh, y to the 4th raised to the power of 0. Anything raised to the power of 0 is equal to 1. Perfectly fine too. Either way. There's not even any work to really show, especially on 13. It's not like you can expand it out 0 times, right? That doesn't make any sense. That's all I need to see. 1. All right. 16. This is another one of those two-part rules. First, we're going to solve this little section, once again using the power rule. So we distribute that 3. We get x to the 5 times 3, which is what? 5 times 3 gives us something. 15, thank you. Now we're going to have to use our product rule. Okay? X to the 15th times x to the 7th is just x to the 15 plus negative 7. Got you. Plus next to a minus makes a big ol' what? Minus. And 15 minus 7 is 8. Oops, there it is. All that work just to give us x to the power of 8. All right. Now, number 18, I'm just going to drop right down here so I can keep 16 in view. Number 18, if we have y to the 4th raised to the power of 0, what is this whole section equal to? 1. Bring down the times y to the 3rd. And what's 1 times y to the 3rd? Ooh, that's like 7 different answers. What's anything times 1 equal to? Itself. So 1 times y to the 3rd is y to the 3rd. Right? What's 1 times 2? 2. What's 1 times 1,000? 1,000. Anything times 1 is just itself. What's up? You could have used the power rule, multiplied it, got y to the 0 times y to the 3rd. Good question. That's exactly what I was about to bring up. Y to the 4th raised to the 0. I do not want you to accidentally call that y to the 1st. Okay, y to the 1st is 1 more y than y to the 0th. They are not the same thing. So when I say that this whole thing is equal to 1, I don't mean 1 as an exponent. I mean 1 as the answer. Just 1. And that's where a lot of people I saw making mistakes on the booklet yesterday. I think this may have been on our quiz. If not, it was on a worksheet that I know a lot of people got wrong. Keep that in mind, okay? Replay this part of the video 20 times if you need to. This whole thing is 1. Not y to the 1, but 1. All right? Great question. Good to bring up. Over to 17, last of our little exponent rules here. What is this rule called again? Quotient rule. Good. Oops. Quotient rule. And this is another one where it's trying to trick you into dividing the exponents. But we never, ever, ever divide the exponents. Instead, what are we going to do? Subtract. 24 minus 3 is 21. Right? 9 plus 10. 8 to the power of 21 Once again, is that something we could do by hand or should do in our heads? No, leave it like that.
What if we do it though?
If you do multiply this out 21 times, you will run out of time and not finish your test. So just keep it like this. Like I said, this is going to be in like the 100 millions, even like a billion or something. So I'm not going to take the time to verify if that's right on my calculator, so don't even waste your time doing it on yours. Yeah, it's a huge number that we don't even care about. Leave it like that. All right, we got to get through here. Scientific notation. 1,500,000. Is that large or small? Large. Let me switch up the colors here for a second. Hold on. I'm tired of seeing red. This is a large number. So what type of exponent are we going to have? Positive or negative? Positive. Good. Positive exponent. Add that in there if you need to. Now in this number, where is my decimal at right now? On the very end. Where do we want it to be? Between 1 and 5. Exactly. 1.5 is going to be my new leading number. Times 10 to the power of something. Let's count it out. 1, 2, 3, 4, 5. Thank you, Darius. 6 spaces means we've got 10 to the power of 6. Positive 6 or negative 6? Positive 6. Question?
On the test, we also have to write how many spaces.
You don't have to write how many spaces, but you do need to count using the bubbles. I mentioned that when we learned it. I need to see the bubbles. That's the only work you need to show. Like I said, when there's 20 zeros and you're trying to count them all, you're going to skip one. You're going to double count one of them. Go in between each number, please. It's for you, not for me. Now, is number 20 a large number or a small number? How can we tell it's a small number right away? Starts with 0. Thank you, Brooklyn. Absolutely. Starts with 0. There's my decimal. Where do we want it to end up? At the end? In between 7 and 8. Good catch. 7.8 will be my new leading number because 7.8 is in between 1 and 10. If we brought this decimal to the end, we'd have 78. Is that in between 1 and 10? No, way too big. So we'll count it over. 1, 2, 3, 4 spaces. 7.8 times 10 to the 4th. Yes? No? Good. Thank you. I appreciate that. Negative 4. Small number, negative exponent. Like I said, add that in if you need a reminder. It's also in our notes, but if you need a reminder on this, there it is. All right, 4 more to go. Let's flip it around, go from scientific to standard down here in 21. Is this going to be a large number or a small number? Large. How can we tell? Positive exponent tells us we've got a large number. It's especially important here because the size of our number determines whether we're going to move that decimal to the left or to the right. So we'll rewrite our number, 6.7. Are we going to move this to the left or the right? To the left. So my zeros should be in front for a large number. To the right. We want my zeros to be on the end for a large number. 1, 2, 3, 4, 5, 6 spaces because that's my exponent. Thank you. 6 spaces because that's my exponent. And what do we fill in with all these bubbles? 0, 0, 0, 0, 0. We'll rewrite this number as 6,700,000. On the test, as you'll see tomorrow, the right-hand column is where you'll write all of your answers. Okay? So no need to box them up on the actual question. You're going to write them in these boxes on the right. Okay? Huh. Okay. Good talk. All right, let's take a look at number 22. We're going to have a large number here or a small number here? Small. How can you tell? Negative exponent. So do we want to move this decimal to the left or the right? To the left. To the left. We want our zeros in front if we have a small number. 2.5. How many spaces do we move that decimal? 4. 1, 2, 3, 4. Fill in with zeros. 0.00025. Whether you write an additional 0 to the left of your decimal or not is fine. You could leave it as 0.00025, or you can add that 0 in front. Mathematically, they're the same exact thing. All right? 2 left to go, and we got 8 minutes. We can do it. These are the most recent. Everything okay? These are the most recent lessons we learned, so they should be fresh in our brains. 23. We're going to multiply these two numbers. 3.4 times 5. That's my step 1. Gives us 17. Exactly? Oh, yeah, good. 17. Is that in between 1 and 10? No, it's not. We'll come back to that. Step 2. 10 to the 5th times 10 to the 3rd. We're going to use what type of rule here? Something like that. You're on the right track. It starts with a P. Good guess. Product. This is the product rule. Go ahead, Darius. Product rule. Because we have like bases that we are multiplying. So what do we do with the exponents? We add them. 5 plus 3 gives us 10 to the power of 8. All right? That's right. Let's put them together. 17 times 10 to the 8th doesn't look quite right. So what do we need to do?
Add a decimal between 1 and 7.
Good. Okay.
So like we're taking the decimal from the 4.
In a way, yeah, I kind of see what you're saying. If we have the number 17, where is the decimal in this number? At the end. Where do we want it to be? In between 1 and 7. How many spaces is that? 1 space. So what do we do with our exponent? Add 1. Be careful, because the last lesson we learned, we subtracted 1. We'll get to that in number 24. So our new number becomes 1.7. Is that in between 1 and 10? Yes, it is. Times 10 to the power of 9. There we go. Okay. Last but not least, 24. We're going to treat this like 2 separate problems. The first of which being 4.25 over 5, which is equal to like 0.85. I trust you all. That sounds good to me. We'll have to change that in step 3, but let's do step 2 first. 10 to the 8th over 10 to the 4th. What's this rule called again? Quotient rule. Beautiful. Which means we're going to keep our base the same and do what with our exponents? Subtract. We get 10 to the power of 4. Thank you. We'll put them together in step 3. 0.85 times 10 to the 4th. Again, that doesn't look right. We're going to move our decimal how many spaces? Once. And what do we do with our 4? Subtract 1. Keep in mind, very similar process, very different results. Adding 1 versus subtracting 1. Make sure you know the difference. So this gives us what? 8.5. Is that in between 1 and 10? Sure is. Times 10 to the power of, oops, can't see it. Times 10 to the power of 3. There we go.
Wait, can we use this one?
Of course you can. I wouldn't spend 40 minutes talking about it if you couldn't use it.